Hey guys, welcome to a new video in this neural networks and deep learning tutorial. In this video here, we're going to talk about convolutional neural networks. So first of all, we're going to cover the basic stuff about what convolutional neural networks are and what different kind of elements does it contain. And then we're going to talk about like what we can use the convolutional neural networks for and stuff like that. And then in later videos, we're actually going to create our own convolutional neural network, train it on an image data set, and then do predictions on data that the neural network hasn't seen before. But first of all, remember to join the Discord server that I'll link down in the description, where we talk about some different kind of stuff within artificial intelligence, computer vision, deep learning, and neural networks. And also, if you have some problems with your projects, go ask the questions in there, and people might be able to answer you. Or if you just want some inspiration for some of your projects that you're doing, so make sure to join that channel as well, and also subscribe to this channel here and hit the bell notification under the video here, so you'll get the notification when I upload a new video. But I'll jump into the first slide here, where first of all we're going to have a short recap over the artificial neural network that we have been over in the previous videos in this tutorial here in deep learning and neural networks. So first of all, we have some different kind of parameters in our artificial neural networks, where we talk about some weights and some biases for each of those connections here between the nodes in the different kind of layers. And then we're also talking about the classification and regression problem that we can solve by using artificial neural networks, where we have our artificial neural network learning on some data to be able to do actual like classification and regression, so we can like have our model fitting to like a set of data points, and then we can actually like do regression, like some different kind of regressions, and we can also do classification if we want to predict, like as we did in one of the previous tutorials, where we predicted if a patient has side effects or no side effects by getting a vaccine in a trial process. And then we went over the training process when we trained the neural network, like epoch per epoch. So we saw like how the neural network trains, and how also like how it learns. And then we talked about like with the math, some of the math behind like how it learns, and what different kind of parameters can we tune on to make it more stable and also optimize our neural networks. And then we talked about the different kind of elements in neural networks for optimization, as dropout, regularization, and stuff like that, which we can also use in convolutional neural networks. So we're going to cover that more with convolutional neural networks throughout the next upcoming videos here about convolutional neural networks. But we had some different kind of elements for optimization in neural networks that can both be used for artificial neural networks, but also in convolutional neural networks. And then at the end here, we created, trained, and predicted with an artificial neural network from scratch on some random data that we created. So first of all, before we're talking about convolutional neural networks, we need to know like what is convolution, because this is basically what is going on when we're doing or like passing our image through our convolutional neural network. So first of all, convolution is that we have like some different kind of like image down here, which is just like a matrix in this case here, and then we apply some filter on top of that image, and then we do some like matrix multiplication and stuff like that, and then we will get a resulting frame or matrix that we can then use later on to do some other different kind of operations on, where we then apply a new filter on top of that and do some pooling, which we're going to cover more in depth in later videos as well. So first of all, the idea here behind convolution is that we overlay the filter here on top of the image. And then when we apply this filter here on top of the image, then we do element-wise multiplication between the values in the filter and the corresponding value in the image. So let's say we apply this filter here on top of the image here, then we'll actually like multiply 1 here by 1, and then the 0 here by 2, and -1 here by 1, and then so on and so forth. And then we're summing all the products here of the like element-wise multiplications, and this will be the sum of the output values. And when we have multiplied all of these values here with the filter, then we sum it all together, and then this will be the value up here for this filter here when we applied this filter here on the image. And then when we're done that, we're repeating it for all the locations. So we're going column by column, and then row by row. So first of all here, then after we have done this calculation here, then we'll actually like move our filter, or like convolve a filter, and slide it over the image here. So then we will apply the filter on top of this area here instead, and calculate a new value, which will then be this value here. And then we do it column by column, and then after that we go down one row by another row. So this is the idea behind convolution, and this is what's going on in convolutional neural networks, where we have like a lot of different kind of also like kernels, which is also like this filter here. It is both like a kernel or a filter that we then apply to our image, and then we have some different kind of pooling layers, and we apply more filters and stuff like that, which learns different kind of features in images. So here we have a convolutional neural network, which just is like a simple convolutional neural network with one convolutional layer and one pooling layer. And then at the end, because we're doing some classification problem, we need to connect it like our pooling layer or a convolutional layer to our dense layer, where we can actually like get some different kind of like data numbers, which is just like this gets passed through this this dense layer over here. And then at the end here, we will get some values for the classification of the image that we inputted to our neural network here. So we can divide our neural network, our convolutional neural network, up to into two parts here. Where in the first part here, we're doing some feature extraction, where we have these convolutional neural networks, where we apply these small filters on, and then we do all the matrix multiplications in our layers here. And in this case here, per layer, we can actually like have multiple kernels or filters that we're applying to our image before we pass it through to the next layer. And in convolutional neural networks, we often have a convolutional layer, and then it is followed up by pooling. So we have some different kind of methods for pooling, where we can apply max pooling. So we look at an area, and then we take the max value of that area, and then we will like send that value further in the neural network to a new convolutional neural network, and then find some other different kind of features. So this part here of the convolutional neural network is actually the feature extraction. So we're extracting features in the image, so it can be like basic structures like lines, and also like triangles and other different kind of shapes. And then we can come further in our neural network. We actually like can extract more detailed features. So for example, if we want to classify a car, then we can actually like extract some features by the door handle, or like the headlight, and also like the tires and stuff like that. And then when we're done that and we want to do the actual classification, we need to like flatten our convolutional layer to some some data that we can pass to this dense layer here. And then at the end here, you can actually like classify, or like it gives a percentage of how certain it is that this is a car that we're passing through the neural network, if that was the case for our classification problem. So now we're going to talk about some of the applications of convolutional neural networks. So convolutional neural network is used in a lot of different kind of things, and often when you have images and when you have an application that is operating with images, then you will use convolutional neural networks to do some different kind of classification or regression problem. And in this case here, we can see that we have some different kind of classification problems here, where we need to classify different kind of objects when we're driving around in the environment. So over here to the left, we have Tesla's approach to use like convolutional neural networks in their car, together with computer vision. So when the car is driving around, this is actually what the convolutional neural networks gets as inputs from the cameras in the Tesla. So we can see that we have some different kind of classification problems in this image here, where the Tesla car is able to classify some different kind of cars around the car here, and it can also like classify if that car is actually moving, or if the car is parked or braking and stuff like that. And we can also see that we're detecting a stoplight here, and we can see that we get a stop sign here up here in a number of meters, and we can also see that we're detecting like the road lines here. So this is all classification problems that is just combined to one image here. So we have different kind of classification problems. We need like a neural network to predict like the path of the car, and we also need a convolutional neural network to like to predict the lane and the lane lines in the road here that we're driving. And then we also have a neural network that is predicting if a car is moving, or just finding like the box here around the car, which is also like a 3D object detection convolutional neural network that they're running through here. And then over to right here, it's kind of the same here, where it's just a Waymo approach, where it has some different kind of other information and combine it with their convolutional neural networks. But it's kind of the same approach here, where they have some different kind of classification problems, where they have these 3D detection of the car, which is also a classification problem, and they have some different kind of like path like estimations, or like path finding deep neural networks that is running through as well, by just taking input from the camera and other sensors in the car. So it's kind of like the same approach here with the neural networks, where they get some inputs from the cameras, and then they're doing some different kind of object detections of different kind of objects that is relevant for the car when it's driving around in the environment. So now we're going to talk about some different kind of like layers and filters in convolutional neural networks. So we're also already talking about some of it. We have some different kind of layers in our convolutional neural network, and then we also have these filters here, or kernels, that we apply to the images when we pass it through our layers in the neural network. So for example, here we have the first layer here in the neural network. So we have the first convolutional neural network, or layer, and then for each layer we can actually like apply a number, like we specify a number of filters in our convolutional layer. And then we can apply those filters here to the image, which we already went over with the convolutional and how convolution works. So we can actually, like, when we do this and we set up our convolutional neural network, we actually like need to specify what convolutional layer we want to use, because there's different kind of convolutional layers, but we will mostly focus on the two-dimensional convolutional layers in this tutorial here. And then we can also specify like the filter size. So we can have different kind of filter sizes. So the size of the filter that we're going to apply on an image, and we can also have different types of filters. So some filters are good for extracting like in the early stages for like the basic shapes like triangles, circles, and stuff like that. And then we have some other different kind of filters that is better for like extracting more advanced features and stuff like that. So we have these different kind of layers which contains multiple filters that we can specify ourselves. So this is like how we can actually like think about it as neurons in our convolutional neural network, where we have like filters inside of our layers, but we have a lot more parameters here inside of convolutional neural networks, which we'll already also see in the upcoming videos. Because when we have convolutional neural networks, we have actually have a lot more neurons to be able to train when we're passing data through our neural network and when we're training our neural network, compared to artificial neural network, which is also why convolutional neural networks is so good with images, and also like in applications where we're operating with images. So what does the CNN actually like learn? So we already went over this here shortly, where we're actually like extracting or learns like features layer by layer. So first of all, here we can have some lower level features here where we can see like we're detecting like some different kind of shapes here. We get some borders, some shapes, we get some like black and white here. It could be like, for example, color and stuff like that, color like the eye here, and some different kind of like changes in the color or intensity of the pixels, which is actually like corners or edges in the images. So these are the low level features that we're extracting, and we can't really do classification out from just those low level features. But when we pass it through to like the later layers or like the next layers, then we can actually like extract some mid-level features here. So we can actually like start like extracting information about like the eyes. In this case here, we want to like extract some information about the different kind of features in the human face. So now here in the mid-level features, we're actually like extracting some different kind of like, for example, the eye and the nose, as we can see here on the images, and also the mouth somewhere and stuff like that, and the eyebrows. So we're extracting some more features about the human face, and we can actually like already say now that this is about like this is probably a human because we have these different kind of features here. And then we just pass it further to the next layer, and then we can extract more like high level features over here to the right. And then we can see we're actually like combining all of these different kind of features that we have learned in our convolutional neural networks together. And now we can actually like get the different kind of features here of the human face, and we can actually like combine it all together. And then we can see that we're now extracting like whole faces in our convolutional neural network. So we can then pass this data here through our dense layer, and then we can get like a probability of is this a human or not when we're doing this classification problem here, where we just pass this input image here in here to the left, and then we go through all the convolutional neural network layers and also with the pooling layers, and then we extract all of the different kind of features layer by layer. And then we can have these different kind of layers and parameters that we already talked about, and we're going to cover more what different kind of like layers do we have, and also what different kind of parameters do we have inside of convolutional layers, because a lot of the different kind of parameters is the same as the artificial neural network, but they work like, and they also work like kind of the same way, but we're going to talk more about that in the later videos. So how can we create a CNN, like how to specify the parameters, and also like what layers to use, and also we also need to specify like how big of the like size, like how big size do we need for our like filters. So all of these things here, we're going to cover that in the upcoming videos. So make sure to hit the subscribe button and also the bell notification, so you'll get a notification when I upload a video about like how we can create a neural network in Keras, and how we can specify the parameters, how we can like tune our convolutional neural network for a specific application or project that we're going to do. So in the neural networks here, we talked about in artificial neural networks like the trainable parameters in CNN, because these are important information here, so we know like how complex is our neural network, and like how many neurons can we actually like train in our neural network, so it's able to do the actual task or application that we wanted to do. So to actually like find the number of trainable parameters in a convolutional neural network, we have the number of filters here that is specified for each of the layers here. So in this case here we have 2 convolutional layers, and in the first convolutional layer here we have 2 filters that we're going to apply to our input image here. And then in the second layer here we have 3 filters here, where all the filters here in both the layers is 3 by 3 filters. And then we have the output layer here at the end here, which is just 2 neurons for a classification problem. So this is just a simple example, and like to show you like how we can calculate the number of trainable parameters. And as you will see in the upcoming videos here, you can see that we get a lot more trainable parameters in convolutional neural networks compared to artificial neural networks. So these are definitely more complex and can solve more complex tasks and applications. So we have this number of filters here for each of the layers here, and then we multiply that by the number of filters times the size of the filters. So the size of filters is 3 by 3 in this case here, and the number of filters is 2 for this layer here. And then we also, if we're operating with biases which is the same as in artificial neural networks, then we can also like have a bias for all the like the filters that we have in our like convolutional layer. And then when we like put all the numbers inside of this formula here, and then we can actually like calculate the number of trainable parameters in our convolutional neural network, so we know like how complex is our neural network. And this is also the output that we get in Keras when we're calling the summary on our model function. So now we're going to cover like and get an introduction to CNNs in Keras, so like how we can actually like specify convolutional neural networks in Keras. So we actually can create a sequential model as we did in the artificial neural networks tutorial, where we just specify the different kind of layers that we want to have in our convolutional neural networks or in our sequential model. So the convolutional layer that we're going to use the most here in this tutorial is the convolutional 2-dimensional layer here. And then in the convolutional two-dimensional layer here, we're going to we need to specify the number of filters that we want to apply for this convolutional layer. And we're going to cover like how can we like specify and like how can we find the best number of filters for each specific layer. And it really depends on the application and how complex task you want to solve. And then we also need to specify the kernel size, so like the size of the filter that we're going to apply on the image that we get as an input to that convolutional layer. And then we also have some different kind of parameters that we can specify as in artificial neural networks for each of those layers. So we can actually like specify the activation here, and if we want to use biases in our convolutional neural network, if we want to like have a bias for our filters in our neural network when we pass it through. And all of these different kind of things here work the same as in the artificial neural network. And we can also specify the kernel initializer and the bias initializer. And we can also specify if we want to use some regularization both for the kernel and the bias, and also for the activation function. And also we also have some like different kind of constraints, and we can put it into groups and stuff like that. So all of these things here, we could also specify those in artificial neural networks. But in this case here, what is specific for convolutional neural network or like convolutional layers is that we need to specify the filters here and the kernel size of the filters that we're going to apply for that convolutional layer when we pass through our image through the neural network. So that's pretty much it for this video we got here. We've been over like an introduction to convolutional neural networks. We've talked about what is convolution, and we talked about some different kind of applications of convolutional neural networks and how like we can create and like how a convolutional neural network is constructed with some different kind of convolutional layers, and then we're followed up by pooling layers, which is then sent to another convolutional layer. And then we can also have some different kind of parameters in that convolutional neural network. And then at the end, if we're doing a classification problem or a regression problem, we would like to like have our like input or like our image flattened, and then we can pass it through a dense layer, and then we can actually like get the results of our classification problem and like a probability of like if this is a person or not, or some different kind of other application, if it's a cat or dog, just as a simple example. And then we're also sort like the applications of what convolutional neural network is actually like capable of in the case of Tesla and the Waymo that is driving around and detecting some different kind of objects in 3 dimensions. So thank you guys for watching this video, and remember to subscribe button and bell notification under the video here, and also like this video here if you like the content and you want more in the future, because it just really helps me and the YouTube channel out in a massive way, and I really appreciate your support. So I'm currently also doing a computer vision tutorial where in the end we're going to combine it with this deep learning tutorial here, so we can combine convolutional neural networks with computer vision. And I'm doing computer vision in OpenCV with C++ and also in some in Python. So if you're interested in that tutorial, I'll link to it up here, or else I'll just see you in the next video, guys. Bye for now.